So, hello, welcome back. Yeah, now is the time when we continue. Tere tulemast tagasi, jätkame veel kahe esinejaga enne lõunat meie ingliskeelses plokis. It's my pleasure now to go forward with this event and introduce the next two speakers who will be presenting about things in Tallinn, the state of things in Tallinn, also the Green Twins project and much more. So, Abdelrahman and Laura, I welcome you on the stage. You can introduce yourselves and your topic. Go ahead.
Hello, everyone. I'm Abdelrahman and my colleague Laura here. I'm a 3D specialist in the city of Tallinn. And today we'll be talking about Tallinn digital twin progress and our participation in Green Twins project.
Hi, I'm Laura Mrosla. I'm a PhD student at TalTech and Aalto University, and thereby I'm working for the Finnish Center for Smart Cities here in Tallinn, together with Abdelrahman and a lot bigger team. We worked on this project, so it's not only our work, but really representing the work of a bigger group.
Yep, so let's start with our presentation.
So we already heard in the previous presentations quite often, what is a digital model, what is a digital shadow, what is a digital twin. In order not to bore you too much, I will just go very, very quickly through it. So we have the digital model, which is mainly for knowledge representation and the unconnected experimentation. Then we have the digital shadow, which is for prediction and also for database planning. And we have the digital twin for automatic response and decision support. And the main difference, as we see it here, is that the digital model has only a manual data flow, or you can also call it a manual cyber-physical communication, which means there is no automatic updating. Then we have the digital shadow, where it is possible to update from the physical to the digital world automatically, but the feedback from the digital to the physical is still mostly manually done in the digital shadow. And we have the digital twin, where it is all done automatically. And then we already heard a lot about the definition of urban digital twins. So we understand urban digital twins as a container for different 3D models, but also other kinds of models for data and algorithms, which are describing the physical, but also non-physical parts of urban areas. And by this we mean that the physical, of course, we have the buildings, but also the non-physicals, which can be economic, exchange, or things which are not physically touchable. The aim of the digital twin for us is to bring together the formerly siloed information and data, and digital twins allow us to comprehensively also exchange those data and also to support a lot of different stakeholders in coming together to discuss urban challenges.
So, as we're talking about Tallinn particularly, and as my department is the GIS department in Tallinn city, so this is a quick overview of the ecosystem of our department, and most of those sort of assets or factors are the kind of the main seeds that we're going to rely on our way to achieve a digital twins model for Tallinn city. So as you can see, we rely on many things, mainly ArcGIS products, S3 products, where most of our maps and base maps are created and stored, as well as ArcGIS platform, where we are kind of visualizing or publishing some of the products. Some of them are public, some of them are not. Then comes the TPR, which is sort of the informatic system platform, where most of our data are saved. Then also partners is one of the main parts in our ecosystem. We kind of exchange data, information with them and to them as well. Then comes data capturing and analyzing is one of our daily jobs in different types and kinds of data. And then comes one of the main things that we'll be talking about today is Green Twins, which is a project we participated in as Tallinn city. And out of this project, we got to some results that we are trying to utilize them and integrate them with one of our products, which is Tallinn 3D city model. Again, it is one of the things that we're considering to build upon our digital twin project. Maybe next slide.
Yeah, so we're going to mainly talk about the Green Twins project, which is a collaboration, like I already said, between the City of Tallinn, City of Helsinki, the Finnish Center for Smart City, the Tallinn University of Technology, and Aalto University.
Yeah, so the challenges that were addressed while we were coming to this project was first of all to have kind of improved greenery areas, and we wanted to work on the quality of the information models that we have for the green areas in the city. And then second thing comes the how could we develop a sort of more interacting urban planning methods. And for these two main challenges, we kind of targeted two goals. First one is to develop and visualize a user-friendly interface where people can interact with kind of a green layer, digital green layer, and work on it. For both cities, which are so-called the digital twins, or like the green twins. We're talking about Helsinki and Tallinn. And then our second goal was to create a user-friendly physical space, which is Tallinn Hub Avalin, and as well as a virtual digital user-friendly platform for public participation.
So let's talk a little bit more about greenery. We heard a lot about digital twins in general, but mostly it's like you can also see here in this diagram, it's about the terrain, it's about the buildings, the infrastructure, mobility, and like then this digital layer. But what is mostly left out of the discussion is the green layer as well as the social layer, which are not represented at all in most of the digital twin discourses. So that's really the two aspects Tallinn and Helsinki were focusing on within this project. And also if you look at different digital twins a little bit around the world, let's take Singapore. For now, for the publicly available digital twin, they're working only with billboards. Then we have Helsinki, they're having a mesh model, and here in Tallinn we're having a point cloud. The main aspect or the main lag hereby is that greenery is, like I already said, mostly left out in the discourse. Then the flora and fauna is changing diurnally as well as seasonally, meaning it looks totally different in winter than in summer. It grows, it might get sick, there might be a lot of challenges around it which are visible or also non-visible because they're happening underground. And then it's also overly simplistic and a purely static representation of the urban green, despite also the impact the urban green has on the city when we're talking about, for example, all the effects it has on cooling down the city, of air purification, and so on. And also, there's mostly no semantic information. So if you look at those models, quite often we can click on a building, then we can see the height of the building or who owns it or what kind of building is it. But on a greenery, it's just a mesh, it's just a point cloud, it's just a billboard. But we don't know what kind of tree is it, how old is it, are there any problems with it? So Green Twins was trying to work on that. And to start with introducing Green Twins, Shitos will start with the digital plant library, which is a vegetation information system and also used for the projections of the greenery.
Yeah, so the digital plant library basically it's kind of based on 3D models of the plants themselves, and then the most important part comes the algorithm plant models, which is mean to work on the, or visualize the growth of the plants, the change that happened to them over the seasons, and the level of details based on whatever platform you're using or whatever the requested level of details.
To make it a little bit more understandable what we're talking about, like the Green Twins plant library can be understood as a plant information model, like a geo-information model. And on the one side, we have, of course, the data retrieval, which can happen due to drones. For example, one of our colleagues who's in the audience, Xiaowen, is working on AI algorithms who are automatically detecting different aspects of trees, like the height, like the species, and so on. But we're also working with more traditional data sources, such as cadastral maps or any other maps and information which is already at the city department or at the state departments. We're also working with expert elicitations, but this is a very laborious and very expensive approach, meaning that we consult with experts going on site and letting experts detect what kind of species are here, how old are they, and so on. And so then from the data retrieval, it will go to the information model, and from the information model itself, the data is 3D visualized, and also their projections and analytics are done with those data. Furthermore, to create this information model, we are based on CityGML, which has for now only a very limited definitions of vegetation. So we created an extension for CityGML, and we included to this ADE the user groups and needs, and also the interoperability and comparability to other systems.
Yep, so the 3D visualization part of the trees, we basically have multiple stages for it. So starts from the branch itself, and then like when it's planted, and then it comes to the growth of the branch, and we take in consideration many aspects like the gravity, force on it, and then the growth, and then the branch depth. And so that's about how the model is kind of built, how the algorithm works for it. And then comes another thing that we took in consideration, which is the level of details. So we have a very high detailed models, and then a lower level of detailed models for other whatever platform it will be used on, and then the lowest level of detailed, and they are all existing in our data, and we kind of use them or utilize them based on what platform or which kind of application will be handled the existing models. So this is an example of the angle function aspect that is basically the algorithm is taken in consideration. So basically the algorithm plans, it consists of, like explained earlier, there is a growth of the branch itself, and then there are angles that are calculated from the space parametric, and they are not kind of, I mean, they are particular per each space. And then there are 3D vectors that are basically covered with all, like, with multiple polygons to, by the end, visualize basically a recognizable shape of the branch or of the twig that we're working on. Then here there was texture photography and image processing. So that's basically, it summarizes the way that those branches were kind of modeled. So on the right hand side here, this is a 3D model of a branch, and on the left hand side, those are real pictures or photographs that were taken of the actual trees, and they are multiple species in here, as you can see. And the process goes as so: the kind of a high quality picture is taken of a specific sample of a branch, and then out of this picture, the processing stage starts, and then we export out of those pictures the texture that will be added on top of the 3D model itself. And we use the same picture for the, let's say, the 3 levels of details that we're having. And the only difference here will be the kind of the mesh itself, the number of vertices and polygons.
And so what we can see in the dynamic plant library, we have the age, so we can see how, in this example, a tree is growing. Then we can also see here the different level of details, which are mostly dependent on computational power, for example. And then we have the seasonality. How does it look like in summer? How does it look like in winter? And also the different twigs. And we did this plant algorithms and, like Shitos explained already, the branch modeling for various different trees. And here's just a short, not a summary, but overview how different trees could look like. But those are not all the trees which have been modeled. And here is a short...
Yeah, this is basically a quick video that shows a sample of Tallinn 3D model. So we have a public 3D model of the whole city. And this model, it's a public one, so it's accessible for everyone. And if you just Google 3D Tallinn, you can access it very easily. Here we're showing a sample of a pilot area where we're trying to utilize 2 new layers, basically the traffic signs layers, and this second layer which we're talking precisely about here is green twins trees. So this is a pilot area where we have actual data of Tallinn trees in Toom Park area, and then here we use the trees that are exported out of green twins. So the exact location, size, and speed is visualized in here. Those trees are not looking the same. If you see, there is a difference actually in the color tone, and there might be there might be also a difference in the shape of the leaf itself and the shape of the tree based on the species.
Yeah, but it's important still that every tree resembles close enough to a typical tree of those species, and that there are not 2 experimental trees of one species. And then we're coming now to the 3D user interfaces, which have been developed during Green Twins, which are the Virtual Green Planner and Urban Tempo.
So yeah, basically it is important, of course, for urban planning to have a proper 3D visualization, basically to help other stakeholders and other users just to understand how important is the impact of planning proposals, and this basically you can visualize in there all sort of heights or sizes or whatever, and it's of course it's much easier to understand it through an actual 3D visualized asset. Basically the facilitates interaction where people can discuss opinions and decisions based on what is being simulated in front of them. And then comes, of course, the benefits. They are related on the tasks that are planned. And then last thing is, just to summarize it, visualization, of course, is very crucial when planning any sort of, I would say, hard to imagine data or something. So it's much easier to have 3D visualized kind of model out of this data. So one of the products that are done of Green Twins is a virtual green planner tool, which is basically a tool that it's enabling people to create 3D spaces. They can basically create different scenarios. They can imagine they can imagine an existing area. If they will remove a building or add new one, or maybe add a new green area, and then this helps people to, of course, understand how basically is the impact on the specific urban place, or also it helps them to share different opinions or different decisions. And here, this is a quick video that shows a sample of the virtual green planner tool.
This is not the final version yet, it's just a video that has been done before the end of Green Twins, but there should come a new video anytime soon. And the other application is for the visualization of the simulations. It's called Urban Tempo, and there are two main user groups for Urban Tempo. The first one are the facilitators, so those people who want to get the citizens or other stakeholders interact and communicate about the new plans, and the second one are, of course, the stakeholders, which can be then residents or decision makers, developers, and so on. Urban Tempo is designed to be used in facilitated situations, for example, in participatory workshops. Here's an image of Urban Tempo on the left, and on the right side you can see the city hub where Urban Tempo was tested before it was finalized, because one of the key aspects during the whole Green Twins project is that we have had a lot of interactions with a lot of different stakeholders, with urban planners, landscape architects, with citizens, with city authorities, and so on, to get as much feedback as possible during the process of development, and then to present a finished product at the end and then get feedback after it might be too late already. And here you can see the different aspects of the temporality, which can be, for example, modeled or simulated rather than modeled in the Urban Tempo application. And here you can see like a time lapse and a little bit condensed version how the trees are growing. So they can grow quite slow, and then there's this shift. So you can imagine how the different stages would look like, and without seeing like half an hour video. And then we're talking now about the complexity of cities. As we already mentioned at the beginning, Green Twins and the cities of Tallinn and Helsinki emphasize a lot public participation, the opinions of citizens, and those non-directly measurable inputs of cities. So if we look at an still abstract version of a real city, but we see there are people, there's IoT data networks, and then if we have a look at the digital twin, it's quite abstract. But what is important for Tallinn especially is the people, the network of the people. What kind of relationships do they have among one another? How do they trust each other? But also, how do they feel or have a sense of belonging to certain sites? How do they want that their city evolves? This is something we can't measure easily. This is something where we can't put just a sensor on. We track it, and then we have it in a digital twin, and then AI will say, okay, this we will have, and we'll be fine for everyone. So for Tallinn, the thing is, technology is not the problem. It needs the appropriate role of planning, and the technology must begin with a conception of planning. And for this, Tallinn and in the Green Twins project, we were focusing on communicative planning support systems. It's quite self-explaining. It's about communication, it's about planning, and it's about support systems. And so the development of the technologies in the Green Twins projects, meaning the digital plant library, the digital tools and software like Urban Tempo and Virtual Green Planner, as well in combination now with the physical space, which we will present right now, are forming one communicative planning support system. And this hub we're going to talk now about is called Avalen. It has been developed also during the Green Twins project, and the city hub is for the collaborative spatial planning. And the City Planning Hub is a physical space with advanced technology, but also with traditional methods of collaboration for serving public discussion and decision-making on the urban planning development. And here we have a quick interview where it's explained.
Public participation is already a part of our everyday work. It is quite evident that we need different tools to engage different stakeholder groups. The Avasõnad Participation Hub is a co-creation space designed for city officials, the citizens of Tallinn, and experts. It is meant to feel like a living room. It is equipped both with digital tools as well as old-fashioned ones to engage all stakeholder groups. And it's designed for workshops, discussions, and events that should happen before arguments arise.
Here's a quick video of the empty space. We're still collecting photos of when it's in use. And it's also possible, if you have some spare time this afternoon, for example, to go there. It's in the city center, just on the opposite street of Vabaduse Valjak. Here we have a short summary again about the Green Twins.
Green Twins is creating a layer of dynamic digital plans for the forthcoming urban digital twin of Tallinn. The digital plans grow over time and change with the seasons, thus giving a better understanding of how green areas will look in the future. Citizens, planners and other stakeholders will be able to view the dynamic digital vegetation through software applications developed specifically for that purpose. The software application will be available for the public in a physical space, the Avasõnad Smart City Planning Hub in the city centre of Tallinn.
Yep, so we're finished
And
quite on time. Yeah.
Thank you.
Thank you very much for your attention.
All right, thank you. I was just wondering, if the climate is not what you expect, do the digital trees know how to grow? Like, if it's cold for 5 years, then I presume they grow less?
This would be the next step where colleagues of ours are continuously working on, but as trees are depending on a lot of different parameters, like you said already, the temperature, but also the solar radiation and nutrients in the soil, how are they maintained, if they're cut regularly or not, and a lot of other parameters where up to today we don't really know what is influencing a tree to which degree. So the idea would be to monitor, for example, via satellite imagery or drone images with LiDAR and so on, how the trees grow, and then develop algorithms for automatically detecting this to then nurture automatic growing algorithms. But this would be the next step. But Green Twins was a limited project.
Your trees just grow averagely.
For now, yes.
Yeah, okay. Well, thank you.